Yeah, so welcome to lecture 6, that is the effect of climatic factors on crop growth. So the earlier lectures we have discussed about this crop growth and development, the factors of the crop growth and development and crop growth laws, which carries forward for this in simulation exercise for the principles of the growth laws. They are also applicable for the crop growth simulations. So, today we will discuss about the climatic factors, particularly on crop growth and development. As you see the climatic factor, when you go for this simulation exercise, the climatic factors that plays important role for the crop yield predictions, in addition to the soil and the weather, soil and other management factors. So, looking at the climatic factors, if you see, so they are the we have discussed also in before. So, they influence the growth of the crops, the developments and the yield you get, the crop yield, and also distribution of crops over the climate, that depends. The climatic factor mainly the I can say the light, that is solar radiations, temperature, the rainfall, humidity, wind and the atmospheric composition, means your the carbon dioxide contents and other the aerial composition that influence the crop productions. You can see these factors that contribute to the photosynthesis, that is a conversion of carbon dioxide to carbohydrate, and the respiration. In the process some of the assimilates, they are lost respiration, because photosynthesis respirations that is required. And so, from the photosynthesis and respiration we get the net assimilations that leads to the conversion of the carbohydrate to the plant tissue formation and dry matter accumulations. And this also influence the water balance, of course, the phenological development of the crops, and the water balance, the uptake of the water and nutrients from the soil. See, now understanding these effects, particularly the climatic effects that help in proper crop planning. And to grow the crops as per the specific to a particular location, particular weather. Say that indicate the varietal selections, how you can select the crops depends upon the rainfall distribution, temperature, we can select the variety, and of course, the scheduling of the field operations, the input management, that depends upon the climatic factors. So, also give from the India Meteorology Department. So, they have the different agrometric field units. So, we are also one of the centers, the IIT Kharagpur, say AMFU agrometric field unit, where we do give advisory to the farmers twice in a week, every Tuesday and the Friday, about the future weather forecast for the coming 5 days, and also the crop operations, field level operations based upon the weather parameters, looking at the rainfalls, looking at the temperatures. So, we do find out based upon the rainfall temperatures, there may be it influence the pest and disease occurrence. So, in view of that ones, that the pest and disease and other operations depending upon the crop growth stages, either the water applications or the fertilizer applications, that is advisory is given as per the weather condition. Suppose there is the forecast of the rainfall for the coming 2 or 3 days, and if the crop is that stage that needs no irrigations, we can advise farmer to stop the irrigations, because the rainfall is expected. Similarly, the nutrient application also or the pesticide applications can be eliminated, cannot be recommended if there is a chance of the forecasting of the rainfalls for coming few days. So, based upon that, so because of this weather that plays a critical role for the crop planning, the farm planning, the input management that leads that is regulated by weather advisory. So, particularly the climate influence climate on crops. So, crops how they that climate determine the suitability of the crops in different regions, because the crops grows different region based upon the climatic conditions, they are the weathers, because we have the like different rice, we grown in the humid tropics, high rainfall regions. We can see the many millets, small millets now they are grown in the dry regions, or the semi-arid tropics, and so wheat is grown in the temperate climates like the northern atmosphere, the UP, Punjab, Haryana, those are grown for the wheat. So, based upon the climate, so the crops are grown as per the climatic condition. Of course, then soil also, you see the I discussed earlier the soil also. So, the that also influence the because length of growing periods, that depends upon the climate, rainfall patterns. So, using the rainfall pattern, we calculate what is the length of crop growing periods for a particular locations, that is based upon the how much rainfall received for that regions, and we calculate based rainfall received in the week wise, and also this is the amount of evapotranspirations, how much water loss to evapotranspirations. Based upon this, we calculate length of growing periods, and that helps proper crop planning. If you know the rainfall of particular locations, you can calculate the length of growing periods, and based upon that we can select the particular crop and the varieties for that locations. And of course, that is based upon the climate, we get the sowing times, because if you know the length of growing period is 120 days or the 150 days, based upon that we do select the crops, and also we select sowing time in such way that critical stages they of the crops that do not suffer from the either the water and the nutrient stress, like the flowering stage, flowering, or the stage crops critical as per the crop specific critical stages, they do not suffer from any type of the stress, particularly for the rain-fed regions. If there is no irrigation facility and there is a weather abnormality, there may be dry spells. So, to avoid the dry spells, if you have the proper weather forecasting, accordingly sowing or the planting can be planned. And similarly also if you know the soil moisture is very important for the sowing, for the germination of the seeds. In that case also we look at the weathers and look at the soil moisture status, then you can advise for the proper sowing time, so that the crop can germinate and can have a good stand establishment. So, of course, that weather that influence the pest and disease occurrence, because pest and disease, because high humidity, the area is high humidity. So, that encourage that is a very congenial environment for the pest and disease. So, looking at this also you give advisory to farmers, how can if there is a forecasting of the pest and disease, so you can advise farmer to apply any corrective measures, control measure, so that they can take care of this crop from the pest and disease occurrence. So, this is also act as a foundations for the, because as I discussed earlier, agroclimatic zoning that is done based upon the weather and the soils, and so also we go for the crop diversifications. So, we will discuss slowly the effect of the climate, particularly for the light, that is solar radiation, how solar radiations that influence on crop growth. Solar radiations, you get the only form of energy we receive from the sun's in the earth's surface. So, that the radiations there is a that influence the crop growth, particularly the quantity of the radiation, the intensity of the radiations, light intensity, and the light quality and the light duration. These three are very important as for the radiation. Light intensity, because amount of solar radiations that is received on the earth's surface, that we can express as a megajoules per meter square per day, or also watts per meter square, how much radiation is received on earth's surface. So, then also light quality indicates the wavelength, the particularly for the crops we are the concern about the light as a photosynthetically active radiation, visible lights. So, within the 0.4 to 0.7 micrometers, that is important for the crop production point of view. So, how much do you receive the photosynthetically active radiations that can influence the crop growth and development. This will be discussing about the the light quality, of course, in the next chapters, how the particularly the effect of the solar radiations in the crop growth and yield formations. And there are the then light durations, the duration, how much the sunshine hours you can say, sometimes maybe 10 hours, 12 hours, 14 hours. So, different durations. So, as per the these slide durations, we have the short day crops, so you can see long day crops or the day neutral crops. Short day crops are usually grown, they come to flowering when the day length is in the decreasing mode, the decreasing trend, then the short day crops they come to flowering, they say short day crops, because the flowering takes place when the day length is the decreasing, and long day crops where the flowering takes place when the day length is the increasing trend, say long day crops. Particularly if you grow the crops like in the monsoon seasons from June to September, October, the crops are grown, they are mostly short day crops, because when the flower starts day length towards the decreasing trend, say short day crops. Long day crops, particularly winter crops, say long day crops, because the flowering takes place when day length is the increasing trend, like wheat, barley, oats, they are long day crops. Day neutrals like maize, cotton, sunflower, day neutral. So, if you can see one like how the day length that influence this the flowering one, or the classify the crops short day, long day and the day neutral crops. Just one example here. So, if you see the equator, if you see the short day, long day crops, how they are classified, see this is the suppose north latitude, this is the 0 degree and the day length in hour. This is the 12 hours day length, you can have the 10 hours, 8 hours, 6 hours, 14, 16, 18, the day length. If you see the 0 degree at the equator, so almost the day length remains day and night remains same. If you see the month, you can start from the January, then June and December. So, throughout the year, the equator region 0 degree, the day length remains almost 12 hours. If you go to northern latitudes, particularly the day length increases towards the June and then decreases. Suppose 20 degree north, if you go still north 40 degree north. So, for this location if you see the June, May, June, the day length sometimes becomes almost 20-22 hours day length. So, the crops are grown during the June to December, these are the crops we say wet season, wet seasons, those crops are known as the short day crops. Short day crop, because you see the flowering happens when there is a, if you grow in June, July, harvest in December, the flowering happens when day length is the decreasing trend. That is the short day crops where the flowering takes place when day length is decreasing, and the crops are grown between the, you can say winter crops December, January to June. So, these crops are known as the long day crops. Long day crops, and they are grown during the dry season. So, where the flowering takes place when day length is in the decreasing in the increasing trend, day length start the increasing trend where the flowering takes place, we can say the dry season crop, the long day crops. So, mostly the winter crops we carry the long day crops, and the wet season crops they are the short day crops. But what I can say now, the because of the varietal development, now this is a diversity. So, the crops like rice is a short day crops, but rice is also there are different varieties, this is also grown during the dry season. So, varietal development Now, this varieties coming crop, there are varieties which can be grown throughout the year also, but in particular if you see the traditional varieties, the traditional variety rice, so usually grown during the wet seasons is a short day where the flowering takes place at the decreasing day length, and the wheat crops, winter crops, they are grown during the winter season, the long day crops where the flowering takes place on day length, the increasing trend. Day neutral crops, they are influenced by the day length. So, the flowering trend is not influenced by the day length. So, they can be as a 12 to any sorry. So, these are the how the crops short day, long day crops. Day neutral crops like maize, cotton, sunflower. So, they are not hardly they are the flowering hardly influenced by the day length. And light quality as discussed, light quality is the wavelength. So, you have the the wavelength region 0.4 to 0.7 micrometer, that is the photosynthetically active radiation, that is the light quality that is used for the crop growth and development for photosynthesis. Shading also, there is a shading that because of the there are some cases that lowers the crop yield, proper light not received. Optimum light use depends upon particularly the leaf architecture, leaf orientation, canopy architectures, plant density, that indicates the light interception. That also we will be discussing the next lectures, how the solar radiation can be interception can be used for the biomass and the yield simulation process. And particular temperature, if you see the temperature that how the temperature does influence. So, the biomass, if you calculate the biomass, if you see the biomass, when you go for the biomass of a crop, that is a gram per meter square. Say growth rate multiplication of growth rate, that is and growth duration, multiplication of growth rate and the growth duration into growth duration. Growth rate is a gram per meter square per day and growth duration in the day. So, if you multiply these two, that gives gram per meter square. So, biomass, that is a gram per meter square. So, multiplication of growth rate and growth durations, this growth rate, this is mostly influenced by this radiation. Solar radiation plays a important role to calculate or to determine the growth rate, how much biomass can be accumulated in the gram per meter square per day, and the growth duration, that is duration that is regulated by the temperature. So, the solar radiation temperature, these two weather parameters, they regulate the growth rate and the growth duration. Other parameter, of course, the rainfall, water, humidity, they are of course the part of the sum, but majorly the radiation contributes to growth rate and the duration that is decided by the temperature. So, duration growth means the developmental phases. I have discussed earlier the developmental phases, appearance of flowering, appearance of leaves, then appearance of fruiting, then maturity. So, these are the dependent upon the temperature. If crop does not get the optimum temperature, there may not be phenological development proper. The transformation from one phase to another phase, that depends upon the accumulation of proper thermal units, then the crop can transfer to different growth phases, developmental phases. So, that duration is influenced by this the temperature and the biomass accumulations, photosynthesis, that is influenced by the radiation. So, these two will be discussing how the temperature and the radiation, they are used for the growth and the yield simulation. But here the effect of radiation we have discussed. If you see the temperature that influence the duration, because the temperature, this is germinations, growth rate, and those are the mostly developmental phases. They are influenced by temperature, germinations, growth rate, flowering, maturity, they are regulated by temperature. So, each crop it has the cardinal temperature, you can say minimum temperature, optimum temperature, maximum temperature. This is a crop specific, because the temperature below the minimum, that is a base temperature also, of course. So, the crop growth and development stops below the minimum temperature, but the optimum temperature, the growth is at its peak, the developmental phase at its peak when the temperature remains optimum. Maximum temperature, maximum boundary. So, beyond maximum temperature, again the crop may suffer from this growth and development. So, the requirement of the optimum temperature differs for the different crops, like you can say the wheat crop, it has 20 to 25 degrees Celsius, rice has optimum only 25-30 degrees Celsius. So, but low temperature, so the are very high temperature, so as we discussed that because the optimum the temperature is not optimum. So, in case of model for the optimum temperature, the process is conditioned to its rapidity. We give the factor almost 1. So, any temperature beyond optimum, but in between minimum and maximum, the factor we give the less than 1. But if below minimum temperature, so there is no development. So, this already the crop growth and development stops. So, that is a delayed germinations, poor tillering, or the sterility happens, the temperature is very low. High temperature also, that causes heat stress. So, pollen sterility and yield reduction. So, particularly the rice and wheat crop, any crop, they are very sensitive to high temperature during the flowering stage. So, they need a particular temperature stage specific. If temperature is excessively high, so that causes the stress. So, rice we can have the as a chaffy grains in case of the very high temperature. So, if the water uptake is also reduced from the soil, that causes the unfilled grains because of the heat stress, and this pollen sterility that causes the unfilled grains, then yield reduction is there. So, to know that because of the thermal units, how much thermal unit the crop can accumulate for transformation from the one developmental phases to another developmental phases, that is growing degree days. We will discuss how to calculate the growing degree days, say thermal unit that is expressed as a degree Celsius days. So, every crop in a particular growth stages, they do accumulate a particular thermal unit, a growing degree days or degree Celsius days for transformation from one developmental phases to another developmental phases. So, to manage the high temperature stress, we go for the in case of the planting operations, we go for the as a shading, go for the shade nets, or you can go for the mulching to maintain the soil temperature, so that the crop does not suffer from the, because we can maintain the soil moisture through mulching in case of the high temperature stress. And also we can, based upon the weather the climatic conditions, weather conditions, we can go for the adjusting the sowing operations, the sowing time, so that the to avoid the any stress on the critical stages of the crop. And you see the rainfall and the moisture. Rainfall is the let us say that provide in case of the rain-fed ecosystem, the quantum of rainfall and the distribution of rainfall. This is very important, because the crop depends upon the water, not only the quantum, how the rainfall is distributed during the growing season. So, what we see because of climate change, what we are getting the rainfall quantum almost similar. There is no change, particularly in a location you can see Kharagpur location, see we receive almost 1450 or 1500 mm rainfalls in a year, and in 80% of the total rainfall received during the monsoon seasons, particularly June to September, October, and the quantum of rainfalls remains same, but what we see, there is a variability in the rainfall amount. Sometimes we get the very heavy rainfall for the few days, and the next few days there may be drought. So, that causes the deficit rainfalls or the excess rainfall, that is very harmful for the agricultural productions. So, that is a major concern for the scientists or engineers, how to take care of the weather variability. You can say the in seasonal weather variability, there may be drought there may be the excess waterlogging. So that's causes the lot of problem. So you have to go for technology, whether the how to manage the moisture stress, and we can have to how to also there is a facility for the water conservations and case of excess rainfalls and also drainage. So similarly, humidity, wind and atmospheric composition, they also influence the one way for the evaporations and transpirations, that is a productive loss of water, that depends upon the humidity. High humidity that encourage that say congenial atmosphere for the pest and disease. So we have to take care of the crops on high humidity conditions. Low humidity, there may be more loss of water through evapotranspiration. We have to see the irrigation facility, and the wind also that helps in the exchange of the gas exchange and the evapotranspirations, and the atmospheric compositions, particularly and that is a composition of atmosphere that influence production for the C3 crops and C4 crops like different crops. So these are the climatic factors that are already given. So how we can take care in case of the wind, particularly we go for the wind break. Trees are there to protect the crops from the heavy strong winds, but these are the factors which influence the crop growth and development to different effects. So, but the combined effect, the interaction of these factors, particularly not in single, but exposure, crop performance depends upon the duration of exposure of these climatic factors on the crops. So that indicates either light, carbon dioxide, temperature, humidity. Then you go for the adaptation strategies, particularly we look for the resilient varieties. We can tolerate the water stress, tolerance to water stress, resistant to many pests and diseases, and adjust the cropping seasons, the sowing times, and go for the life saving irrigation options to avoid the effect of the climatic factor, stress of climate on the crop growth. So what you can say, what are the summary and takeaway from here? The climatic factors are the fundamental drivers of the crop growth, development, and the particularly the productivity. Light, temperature, and the moisture of the physiological impacts you can see on the photosynthesis and the productions of the crops. Then humidity, wind, carbon dioxide that influence the transpirations, disease incidence, and the carbon assimilation process, and the balanced management of the climatic effect that can ensure this stable and the optimal crop planning. So in that also, if you give the proper advisory to the farmers based upon the other parameters, we can save the crop from the any loss or the damage due to the weather abnormalities. So in future, if you see the long term conditions also, you can go climate smart practices like mulching to take care of the soil moistures, and also intercroppings has a crop diversity, shading of the and the irrigation shielding, the life saving irrigations that is required to avoid any loss to the crop production. With this, I thank you all.